So the first thing they say is write in sigma notation and evaluate the sum of the terms. And this is what the general term looks like. And our indexing variables ranging from 1 to 100. Okay. So if I were to write this down, I think I wanted to say, I'm calculating an infinite sum. My sum is going as I goes from 1 to 100. And I'm going to have I minus 3 squared like this. And my goal is to end up with a number. So I just want to have one number at the end. And what do I know? I know that I can use any of these rules here, and I know how to add together these three things because I have a formula for those three things. Okay. So what do you guys think I should do first in order to solve this problem? Does anyone have any suggestion for me? What do I do with this guy? What would be the very first thing you would do? Any thoughts? Any thoughts? Well, I'm trying to write, in the end, I'm hoping to get, summation of I squared, summation of I, summation of some constant. And the reason why is because I have a formula for the summation of I squared. I have a formula summation of I, and I also have a formula for the sum of a constant. So from my point of view, I feel like the first thing I should do is I have all of this stuff buried inside of a parentheses. So I'm going to expand this guy out first. So this is going to be the sum as I goes from 1 to 10. I'm sorry, 1 to 100. It's going to be I squared minus 6I plus 9. That makes sense for everybody? Then what I'm going to do next is I'm going to use the sum and the difference formula. So this is going to be the summation as I goes from 1 to 110. This will be I squared minus the sum as I goes from 1 to 100. This will be 6I plus the sum as I goes from 1 to 100 times 9. This is still not exactly how I want it yet, but we're getting close. So you can see that I have a sum of I squareds. So I can really use this second formula right here. I have a sum of a constant, so I could really use this guy right here. But this is not exactly the sum of i's. So I'm going to take one extra step just to factor out this 6. So when I do that, I'm going to get the following. I can just take this 6 and move it out here like this. And now I'm good to go. So I'm going to use those formulas up top over here to evaluate each of these things. So since this is your first time seeing it, I'm going to rewrite the formulas right underneath here. So this should be the summation of n times n plus 1 times 2n plus 1 all over 6. This one is n times n plus 1 divided by 2. And this one is n times c, which c in this case is 9. Okay. So we need to acknowledge that when you're going up to 100, they're basically telling you that 100 is n. So I can just write in the different pieces here. So this is going to be 100 times 101 times 201 all over 6. This guy is going to be -6 times 100 times 101 all over 2. And this guy is going to be 100 times 9. Did anybody have any questions about this so far? No questions. Okay. So if you pop these guys into your calculator, you're going to get 338,350 minus 30,300 plus 900. And I end up with 319,550. So that's going to be our final answer. Does that make sense? Is there any questions? No questions. All right, cool. So let's take a look at example 4. Remember, we're still just trying to get used to sigma notation. I'm going to get to all the rectangle stuff in a little bit.